Now that we've completed the algebra review, we're going to move on to the trig portion of our pre-calc class. And in fact, this the rest of this term is almost exclusively trig material. We'll be working with sine and cosine. We'll talk a little bit today about SOHCAHTOA, which might be something that you remember from a previous class. We'll also look at special triangles, 30, 60, 90 triangles, 45, 45 triangles, to help us introduce our trig in this unit. You started yesterday with the angles, degrees, and radians, and we talked all about the degrees and radians, but today we're going to particularly focus on the radians part of it. And in fact, we're going to bring our radian measure of angles together with something called the unit circle. So I've already drawn my unit circle, and take the time on your notes to do the same. It is a circle with a radius of 1 unit. And so here's my circle with a radius of 1 unit, which means that if I were to find the length of this line right here, that would have a length of 1, because from the center to a point on the circle, that would be the radius. So if I was going to think of this as an actual coordinate plane and think about coming up with a point that represents this initial spot 0 pi, hopefully it makes sense to you that that would be the point 1 comma 0, because that would be moving 1 to the right and 0 up or down. I could move around the circle and do the same thing up here at pi over 2, at that spot pi over 2, that's the point 0 comma 1, because again, I don't move left or right, I just move up 1, because this is a unit circle with a radius of 1. If I move over here to pi, knowing that I'm moving to the left, that would be negative 1, 0, and then as I continue down to the bottom, 3 pi over 2 is another axis point, that would be 0, negative 1. And then if I go back up to the beginning to 2 pi, I start all over again, and that comes back to that point 1, 0. So 0 pi and 2 pi share the same value. In fact, if I keep going around and around on the unit circle, which you saw yesterday when you were graphing angles that you can do, continue to move around and around. If I continue to go around and around, 4 pi would also be 1, 0, and 6 pi would be 1, 0, and 8 pi would be 1, 0. And if I go over here to pi, 3 pi, 5 pi, 7 pi, all associated with this same point, because pi and then plus 1 more lap around would be pi plus 2 more pi, or 3 pi, and if I keep doing that, I'm adding 2 pi. All the odd pi's are going to be associated with negative 1 comma 0. And then the half pi's will fall on the y-axis. So those are some main points that we've talked about, but we're also going to focus on 3 more points that are important on the unit circle. And the first one is the one that falls smack dab in between 0 and pi over 2, and that is pi over 4. And then we'll also look at one that is pi over 6, and our last one we'll focus on is pi over 3. Now before we associate pi over 6, pi over 4, and pi over 3 with a point on the unit circle, what I want to do is move off to show you where the points and the values are coming from, because like 0 pi is associated with 1, 0, pi over 4 has its own coordinate point that it's associated with. It's a value that moves x to the right and y up. That helps me land on that point on the unit circle. And to figure out those values, I'm going to draw a right triangle. Okay, what I do next, you do not need to write down, but I do want you to just pay attention to the video. So I'm going off of the notes and looking at a picture that is exclusively associated with this point that we called pi over 4, the one that was smack dab in the middle. So what I need to do first is sketch that triangle that I was talking about. Here's my triangle, and what I want to do is I want to pick that triangle up and I want to take it out of that picture. So I'm going to pick that triangle up and take it out of the picture. Remember, the bottom would be of length x, the height would be of length y, and the point associated with that pi over 4 is going to be the point x comma y. So if I look at my picture of my right triangle, I have x and y, and I know that the radius, because this is a unit circle, is 1, which means that the hypotenuse on this right triangle is 1. All right, so we haven't worked a lot with radians before, but this angle right here, I'll call it theta, and that's just a Greek letter. It's an O with a line through it, theta. So I'm going to call this angle theta, and this theta is equivalent to pi over 4 radians. But I haven't used radians a lot, and so what I'm going to do is convert pi over 4 into degrees. And so I can do that by doing a simple ratio. Pi is to 180, because pi would be over here, pi, and that's halfway around the circle. So pi is to 180 as pi over 4 is to some other angle. And then I'm going to go back into, I don't know, middle school and do a proportion where I cross multiply, and I would say that 180 times pi over 4 is equal to pi times x. So 180 times pi divided by 4, when I do simplifying, I can reduce this here. I will end up with 45 pi is equal to pi x. And if I want to get x alone, I'll divide the pi out. So 45 is equal to x. So pi radians is to 180 degrees, as pi over 4 is to 45 degrees. And again, hopefully that makes sense, because up here would be, right at pi over 2 would be 90 degrees, a right angle, and 45 would be half of that. So my theta here is 45 degrees. If that's 45 degrees, I know this other is 45 degrees. I'm going back to my geometry days, and what I've created is a 45-45 right triangle. And the connection between all of these has something to do with the fact that these two, if these two angles are the same, then these two sides are going to be the same. And so I know that x equals y in this picture. And so again, a 45-45 right triangle, maybe you remember how that 45 right triangle looked. I'll just pull out a different color so I can draw the general form here. If this was 45 and 45, and this was x and this was x, then this was x times the square root of 2. So what this means is that if I know that x and y are the same, and I know that this hypotenuse is 1, and the connection between them is that x times the square root of 2 is the hypotenuse equals 1, then I can solve for x by dividing by the square root of 2. And then I'll rationalize my denominator. I multiply the top and the bottom by the square root of 2, rationalizing the denominator, so x equals the square root of 2 over 2. So I know what x is, the square root of 2 over 2, and then I also know what y is, the square root of 2 over 2, because x and y are equivalent. So this pi over 4 point has an x value of the square root of 2 over 2 and a y value of the square root of 2 over 2. So I'm going to bring that back to my picture. The coordinate point associated with pi over 4 is square root of 2 over 2, square root of 2 over 2. And so that is one of the other values. And in fact, I'm going to write it out here. Pi over 4 has the ordered pair square root of 2 over 2, comma, square root of 2 over 2. Now I want to go back and I want to do the same thing for the pi over 3 and the pi over 6. I'll start with the pi over 3. So again, I'm going to remove my notes and bring a new piece of paper out here. I'm going to do the same thing I did with that one. I'm going to, or with the pi over 4. Pi over 3 is up here. Pi is to 180 as pi over 3 is to, I'll just do a cross product. It's 180 times pi over 3, which equals pi x. And then when I simplify that, I get 60 pi equals pi x. Divide the pi out, 60 equals x. And so I know that the unknown angle, pi over 3, if I draw that triangle in here, that angle associated with pi over 3 is 60 degrees, which means that, again, I'm drawing this, I didn't do a good picture on this. Maybe I'll redo that one, because that is not to the right shape, excuse me, sorry for my choke a little bit there. Okay, so here's that angle. This is my angle, pi over 3. That's what I'm looking for. It'd be better if I called that theta down there, pi over 3. So if I take that picture out, here's a better one, more to like true, similar shape is what I'm trying to say here. So here's my theta, and I know that this theta is 60 degrees, which makes this up here 30 degrees. And so I have a 30-60 right triangle. 30-60 right triangle. Get rid of that. Try that again. That's 60 degrees. Okay, so on a 30-60 right triangle, you may or may not remember, on a 30-60 right triangle, the association is, here's 30, across from 30 is x, across from 60 is x times the square root of 3, and then the hypotenuse is 2x. So all of those values are connected to x. And I know that this is x and y, and I know the hypotenuse is 1. So what I can do here is make this connection. I can say that 2x equals 1, therefore x is 1/2. So I know my x coordinate is 1/2. And then my y is x times the square root of 3, and if x is 1/2, my y is 1/2 times the square root of 3, or I'd write that as the square root of 3 over 2. So what I've just done is created a point for pi over 3 using the special right triangles. So this is 1/2 square root of 3 over 2. X was 1/2, and y was the square root of 3 over 2. So I can go back to my pi over 3 and make that point 1/2 square root of 3 over 2. Let's move it over here where I can see it better. Pi over 3 is 1/2 square root of 3 over 2. And that came from, again, using the special right triangle. 60 degrees is associated with pi over 3, and 60 degrees was an important measure when we were dealing with right triangles in geometry, and pi over 3 is an important measure when we're dealing with our trig functions. Now I want to do the same thing with the pi over 6. So I'm going to go back here and make my triangle again. So I'll create the triangle. Here I am. Here's the angle I'm interested in down here. That angle is pi over 6, and so I want to figure out what that is in degrees. So pi over 180 is to pi is to 180 as pi over 6 is to x. So 180 times pi over 6 equals pi x. When I multiply that, I get 30 pi equals pi x. So when I solve, I divide the pi out, and 30 equals x. So when I translate this triangle, take this triangle, I'm going to take this triangle out, I'm going to make it bigger so I can write all over it. Here I am. This is a 30 degree, 60 degree, this bottom is x, y, and then this is 1. Again, because it came from the unit circle, I know my hypotenuse is 1. And now I want to make that same connection with the 30, 60 right triangles. But this time, y is the short leg. So when I make that connection on here, across from the 30 degrees, if this is y, I know the hypotenuse is twice y, and I know the long leg is the square root of 3 times y. So in this case, the one thing that I know is the hypotenuse again. So the hypotenuse 2y is equivalent to 1, and y is equivalent to 1/2. Hey, this looks really familiar, doesn't it? I just solved something like that, but the only difference is this time I'm solving for y, because where the small angle was across from the side that's standing up, as opposed to on our 3061, where the small angle was, x was across from that. In our picture, because this was this was theta, and that was equivalent to 60, so I found the other one 30, whereas on this one, here's theta, so 30 degrees is across from the height of the triangle. So y is 1/2, and then that means that my x position is the square root of 3 times y, so my x is the square root of 3 times 1/2, or x is the square root of 3 over 2. Oops, that doesn't look like over 2. So again, I can create that point, but this time my x is the square root of 3 over 2, and my y is 1/2. Now I want to put that back onto my picture. Again, reviewing back in our geometry days, special right triangles. This was square root of 3 over 2, comma, 1/2. And pi over 6, I'm going to add that over here, square root of 3 over 2, comma, 1/2. What we're doing today is we are going to be connecting sine and cosine and all the points around the unit circle. So I've picked out some special values. I call these the families. I have the pi over 3 family, the pi over 4 family, and the pi over 6 family. And we're going to be working with these families and working with the quadrants as we move around the unit circle. And we're going to be finding or associating points and values and angles with these families or these points on the axes. So my families, I'm just going to copy those down here. My families, like I said, are pi over 3, pi over 4, and pi over 6. And I'm just copying down the values that I found. I found pi over 3 is 1/2, the square root of 3 over 2. Pi over 4 is square root of 2 over 2, square root of 2 over 2. And pi over 6 is square root of 3 over 2, 1/2. These are very important things that you're going to have to remember. These families are we're going to revisit those over and over and over again, and you need to memorize these. This is my trick. 3, if you look real close, there's not a whole lot of difference in these. There's not a whole lot of things to remember. I have 1/2, I have the square root of 3 over 2, I have square root of 2 over 2, and that's it. Those are the only 3 values that I have to remember, but I have to remember where they go. And so I remember that pi over 3 is 1/2 of 6. 3 and 6 share the same coordinates, just flipped. And so 3 is 1/2 of 6, so 3 starts with 1/2, and then the square root of 3 over 2 comes next. And pi over 6, square root of 3 over 2 comes first, because 3 times 2 is 6, so square root of 3 over 2 comes first, and 1/2 is second. Pi over 4 is the easy one, because that's the one that only deals with the 2 and the 2. Square root of 2 over 2, square root of 2 over 2. It has 2 square roots of 2 over 2. 2 times 2 is 4, so I remember that one kind of that way. Sort of a little repetitious, but I would say take the time and study these, because you're going to revisit, or like I said, we're going to revisit these over and over and over again. Okay? Now I need to go into sine and cosine. And so sine and cosine, we have, I need to make that connection with each of these coordinate points. And so sine and cosine, this is going to go back to SOHCAHTOA. This is a unit circle again. So the hypotenuse is 1. Every triangle that I draw for every angle that I have is x comma y. And so if I think about SOHCAHTOA back in our geometry days, hopefully that looks sort of familiar. This means sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And so if I am going to be looking at this value here, and I talk about, let's start with cosine. I want to start with cosine. Cosine is equivalent, the cosine, it says a cosine of an angle, in this case theta, is the adjacent over the hypotenuse, is x over 1, or the cosine of theta is x. And then if I go to the next one, to sine, I would say that the sine of theta is the opposite over the hypotenuse, so the sine of theta is y. What does that mean to me? It means exactly what it looks like. The cosine is associated with the x-coordinate, the sine is associated with the y-coordinate. So all of my points go in the form of cosine theta, sine theta. That's all the points are going to go in that form. So if I look at this value, what I've just found is pi over 3 family. If I wanted to figure out what the cosine of pi over 3 is, as long as my calculator's in radians, if I plug in the cosine of pi over 3, it will give me 1/2 as the answer. The cosine of pi over 3 is 1/2. The sine of pi over 3 is the square root of 3 over 2. Now these cosine and sine works for all of these values as well. The cosine of 0 pi is 1. The sine of 0 pi is 0. The cosine of pi over 4 is square root of 2 over 2. The sine of pi over 4 is square root of 2 over 2. The cosine of pi is -1. The sine of pi is 0. So the x-coordinate is always cosine, the y-coordinate is always sine. So what we're going to be working with again is working around the unit circle, working with our angle measures. We're going to be looking at things that we looked at yesterday about quadrants that we land in. So let's revisit the quadrants as well. Remember, draw this up on the top of your paper if you have room somewhere. I'm getting kind of scrunchy. Remember, the first quadrant is all positive points. So if I draw an angle that lands in the first quadrant, then both of the points are going to be positive. Notice all of these are in the first quadrant, all of them are positive points. If I go into the second quadrant, the cosine is negative, but the sine is positive. So the x-coordinate is negative, the y is positive. If I go into the third quadrant, it's negative points. That means the cosine is negative and the sine is negative. If I go into the fourth quadrant, I have all positive negative points. That means the cosine is positive and the sine is negative. Okay, so these are my quadrants, my families, my axes, my unit circle, and now I'm going to put it all together in finding values. So we did all of our setup. This says state the ordered pair associated with each of the following. An ordered pair is a point. It's a coordinate point. When I talk about ordered pair, I'm talking about an x, y. And so this is how it works. If I were to give you, it said state the ordered pair associated with pi, we would go to our unit circle and we would say -1, 0. That's it. -1, 0 is associated with pi. But what if I said 7 pi? Well, then I would have to go back up to my unit circle and work around. So as I go around here, this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Oh, it landed in the same spot as pi. In fact, all the odd pi's will. That's also associated with -1, 0. If I said to you, find the ordered pair associated with pi over 2. Well, pi over 2, go back up to my unit circle. That's up here. That's the point 0, 1. Oops, I wrote it down where you couldn't see, 0, 1. But what if I said, what's the ordered pair associated with -pi over 2? Well, now what I did is stick that negative in front of the angle. It doesn't mean it's a negative value. It just tells me that I move backwards. We learned that yesterday. So I move backwards pi over 2. Move backwards pi over 2, that puts me down here at 3 pi over 2. That is the point 0, negative 1. So 0, negative 1 is the ordered pair associated with negative pi over 2. I can do that with the families as well. What's the ordered pair associated with pi over 3? Well, we already found that. That's 1/2, comma, square root of 3 over 2. What's the ordered pair associated with 2 pi over 3? Well, now let's just move around the unit circle like we did yesterday. This is the pi over 3 family, because the denominator is 3, and as long as this is reduced, it's the pi over 3 family. So the pi over 3 family is associated with this point 1/2 square root of 3 over 2, but 2 pi over 3 is in, if I draw that, that is more than half pi, not quite a whole pi. That puts me in the second quadrant. Second quadrant is negative positive points. That means this is a negative positive value. So the ordered pair associated with 2 pi over 3 is negative 1/2 square root of 3 over 2. We're going to continue to work with these ordered pairs, but we're going to look specifically for our answers as sine and cosine. So when I do this next part, I'm going to have the ordered pair. First of all, I'll start with the ordered pair associated with pi over 4. So I go to the pi over 4 family. That is the square root of 2 over 2, square root of 2 over 2. That's the pi over 4 family. I'm interested in the sine. The sine is the y coordinate. So my answer here is the square root of 2 over 2. That's my answer for that problem. The cosine of negative pi over 3. That's the pi over 3 family. That's 1/2 square root of 3 over 2. But negative pi over 3 moves me backwards into the fourth quadrant. So if I'm in the fourth quadrant, that means that the x-coordinate is positive, the y-coordinate is negative. I'm interested in the cosine. Cosine is the first one, so my answer here is 1/2. Again, I'm going to be working around with the families and the axes. So on this next one, cosine of negative 7 pi over 2. So what I'm going to do is I'm going to figure out where that is. Negative 7 pi over 2, I write that as negative 3 and 1/2 pi. That means I'm moving backwards. 1, 2, 3 and a half. That puts me right up here, up on top. That point is associated with that upper spot up here, which is 0, 1. So that's the point 0, comma 1. I want the cosine. Cosine is the x-coordinate, so my answer here is 0. The sine of 35 pi over 6. Again, I go to the family. The pi over 6 family is the square root of 3 over 2, comma 1/2. Well, why didn't I go to the family on this last one? Because any whole pies or half pies are on the axes. And then the families are the pi over 4, pi over 3, and pi over 6. So you're either going to be looking at one of these families or one of these axes. So in this one, I'm looking at the pi over 6 family. As long as this is reduced, that denominator will give me my family. And then I have to figure out 6 goes into 35, 5 and 5/6 times. So when I figure out what quadrant I'm in, I do 1, 2, 3, 4, 5, and 5/6 puts me in the fourth quadrant again. 5/6 is almost a whole pi, so I'm back in the fourth quadrant. That's positive, negative. The sine is the y-coordinate, so my answer is negative 1/2. Again, going through pi over 3. Again, I'm going to speed this up a little bit. This is the pi over 3 family, 1/2 square root of 3 over 2. 11 pi over 3, 3 goes into 11, 3 and 2/3 times. So when I sketch that, that is forward 1, 2, 3 and 2/3. I'm in the fourth quadrant yet again. So that is positive, negative points. I'm interested in the sine. The sine is the y-coordinate. Negative square root of 3 over 2 is my answer. 25 pi over 6 puts me in the pi over 6 family again. Square root of 3 over 2, comma 1/2. Again, that goes right back up to my family. 25 pi over 6, 6 goes into 25 4 and 1/4 pi times. So when I figure out where I am, that's 2 pi, 4 pi and a quarter. First quadrant is positive, positive. I'm interested in the cosine, so my answer is the square root of 3 over 2. I've got a whole pi on my next one. This is sine of negative 4 pi. That means I'm going to be moving backwards to, so 2, 4. I'm right here at the beginning, backwards 2 pi, 4 pi. That is the point 1 comma 0. I'm interested in the sine, so my answer here is 0. And then lastly, on this particular part, I have the cosine of negative 21 pi. Oops, did I move backwards on that last one? I did. Good. Okay, negative 21 pi over 4, so that's the pi over 4 family. And I moved backwards 5 and 1/4 pi. So on my axis, that's back 1, 2, 3, 4, 5 and a quarter. Second quadrant is negative, positive. I'm interested in the cosine. My answer is negative square root of 2 over 2. On the next page, we're going to be dealing with that same stuff. We're just going to take it one step further. So that same stuff, I'm going to take it one step further. Now I'm going to evaluate. So the sine of pi over 3, again, I'm going to be looking at my families, pi over 3, 1/2, square root of 3 over 2, pi over 4, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, and then pi over 6, which is the square root of 3 over 2, comma 1/2. I'm going to be dealing with those families again and working around, doing exactly what we did up to on that other side. So the sine of pi over 3. Sine of pi over 3 means I am looking for the y-coordinate in the pi over 3 family. That's the square root of 3 over 2. I am looking for the x-coordinate in the pi over 3 family. That is 1/2. These are crammed next to each other. That means I multiply them together. So my final answer is the square root of 3 over 4. In here, sine of 2 pi over 3. That's a second quadrant, because it's more than a half pi, but less than a whole pi. Second quadrant, pi over 3 family. So second quadrant pi over 3 is negative 1/2 square root of 3 over 2. That's the pi over 3 family in the second quadrant, negative positive points. The sine is the square root of 3 over 2 minus, then I'll go to this one. This is a second quadrant, pi over 4. So 3 pi over 4 is in the second quadrant. Pi over 4 family is the square root of 2 over 2, comma square root of 2 over 2. Because it's second quadrant, the first one is negative. So this is square root of 3 over 2 minus negative square root of 2 over 2 because I'm interested in the cosine. All I can do in simplifying this guy is make it square root of 3 plus the square root of 2 all over 2. Those are the simplifying like terms. I can't add together the radicals. I can multiply radicals, I cannot add them. Next up, I have the cosine of 7 pi over 6. So again, it's the same thing that we've been doing. This is negative 7 pi over 6, so this is backwards a little more than pi. So backwards a little more than pi puts me in the second quadrant. Pi over 6 family is square root of 3 over 2, comma 1/2. Second quadrant makes it negative. So when I'm looking at this problem, I'm interested in negative square root of 3 over 2. And then I'm going to be multiplying that by this next one, which is the sine of 3 pi. So when I think about 3 pi, that's 1 pi, 2 pi, 3 pi on an axis. That's negative 1 comma 0. In the sine position is 0. Negative square root of 3 over 2 times 0 is 0. So 0 is my answer. I have these same things. I did it again. I have the same values, except for this time I'm looking at the sine of negative 7 pi over 6. So the sine is 1/2 plus the cosine of 3 pi, which is negative 1, 1/2 plus -1 is -1/2. We have one last thing before we go, and that is moving around the unit circle. Remember, I talked about how we work with these families. We just move into the quadrant. So let's put some names to those families. So I'm going to draw this unit circle again, and I'm going to get each of my family members in the quadrant that it belongs and put an actual name to it. So remember, it's pi over 6, pi over 4, pi over 3. Those are my first quadrant families. Those are all positive points. I don't like the way that looks, sorry. Those are all positive points. In the second quadrant, this is 1 pi over 3, 2 pi over 3. That's pi over 3 less than pi. I would take pi minus the angle to get me into that second quadrant. And so if I'm going to be back into the pi over 4 family, it'd be pi minus pi over 4, so that's 3 pi over 4. And then pi minus pi over 6 would be 5 pi over 6. So my second quadrant family members, relatives, are 2 pi over 3, 3 pi over 4, and 5 pi over 6. I do pi minus theta, pi minus the angle, because I'm moving backwards from pi, that same family member length. Now if I want to move into the third quadrant, then I would do pi plus the angle. So I do pi plus pi over 6, 7 pi over 6, pi plus pi over 4, 5 pi over 4, pi plus pi over 3 is 4 pi over 3. And so those are my third quadrant family members. In the second quadrant, they are negative positive. In the third quadrant, they are negative negative. And then in the fourth quadrant, because I'm way over here, I'm going to do 2 pi minus the angle. So I do 2 pi minus pi over 6, that's 11 pi over 6. I do 2 pi minus pi over 4, that is 7 pi over 4. And I do 2 pi minus pi over 3, that's 5 pi over 3. Now, you're going to at some point have to remember these family members as we move around. And if you look closely, they're not so bad to remember. If you look at the numerator compared to the denominator in the second quadrant, the numerator is 1 less than the denominator because we're subtracting that angle from pi. In the third quadrant, the numerator is 1 more than the denominator because we're adding that 2 pi. In the fourth quadrant, it is, because we're going from 2 pi, I double the denominator and subtract 1. In the fourth quadrant, again, remember those are positive, negative points. Okay, so how do I use these to help me? Well, I'm going to be solving equations. And remember that the pi over 3 family is 1/2 square root of 3 over 2. Pi over 4 is square root of 2 over 2, square root of 2 over 2. And pi over 6 is square root of 3 over 2, 1/2. When I am working backwards, I'm asking myself, when is the cosine this angle? And so the cosine, this is the x-coordinate. The x-coordinate is the square root of 3 over 2 in the pi over 6 family. So I know the answer is in the pi over 6 family. And when is the cosine positive? Keep in mind that my points all go cosine comma sine. When is the cosine positive? It is positive in the first quadrant and in the fourth quadrant. So my pi over 6 answers are the first quadrant pi over 6 and the fourth quadrant pi over 6. So I say theta equals pi over 6 and 11 pi over 6. Sine of 1/2. I'm going to do that one quick, and then we're going to stop here, and I'm going to have you work on your homework, and then we'll revisit this tomorrow. So the sine of 1/2, so what I'm looking at, I'm working backwards. When is the y-coordinate 1/2? The y-coordinate is 1/2 in the pi over 6 family as well, so I know I'm looking at the pi over 6 family. but when is the y coordinate positive? Because this one's positive. When is the y coordinate positive? The y coordinate is positive in the first quadrant and in the second quadrant, so it's the pi over 6 family. In the first and second, theta is pi over 6 and 5 pi over 6. All right, so again, I'm going to kind of let it go at that and have you work on your homework, and then we'll revisit this at the beginning of class when we meet again. And then we can definitely ask questions, go over some things, and we'll practice those families and working our way around the unit circle. Please take the time to study these and work with the movements, and we will talk again soon.